What is up, YouTube? Welcome back to another episode on Code with Annie, and in this episode we're going to take a look at the thread lifecycle in detail. So a thread lifecycle basically dictates the different states the thread can be in as soon as it is created until the point it is terminated. So these are the different states the thread can be in. So new, runnable, running, waiting, timed waiting, blocked, and terminated. Alright, so this is basically the entire thread lifecycle, and I'll explain you how this works out. Okay, so to create a thread in Java, basically you have something called as a thread class. So I'll talk about the creation of threads and implementation in a different video, but for now I'm just showing an example. We can create a thread like thread space t is equal to new thread. Alright, so this creates a new thread. So as soon as you execute this particular line, the state of this thread t will be new. Okay, and then to execute a thread, all you have to say is, to execute a thread you have to say t.start, and it will start the thread. Okay, when you say t.start, the thread goes into the runnable state, which means runnable state ensures that the threads which are started will wait for the CPU to be allocated then, so that they can execute the process they are intended to execute. Okay, so it pushes the thread into runnable state and it goes into running state as soon as it gets the CPU resources to execute what it is meant to execute. Okay, so that is the reason why I wrote these two in a comma separated fashion, because these two together are called as the active state of thread. Okay, so when I say the thread is in active state, it means either it is in runnable or running state. Runnable because it is just waiting for the CPU to be given to it so that it can execute what it wants, and running because it is already doing the work that it is intended to do. Okay, so basically what happens is when you have multiple threads in the runnable state, right, so all of them are queued basically in the runnable state, and a scheduler which basically handles all the threads will ensure that the ones in the runnable state go into the running state, and they don't stay in the running state for a very long time. There will be a time slice for which they will be running, and then they will be automatically preempted, and the CPU will be taken from them and be given to the another thread in the runnable state. So at that point of time, those threads which are running will go back to the runnable state. From runnable, again they'll come back to running state as soon as the CPU resources are given back to them for execution. So this is very essential because you have to ensure that in a multi-threaded environment, all the threads get an opportunity to execute whatever code that they are intended to execute. Alright, so these two together are called as the active state of a thread, and then you have waiting and timed waiting. Again, I put them together because just the difference is going to be in waiting, it's going to be indefinite waiting. That is, a thread goes into the waiting state and it will wait indefinitely until some other thread invokes the notify method. Now, there's a lot of confusion between on this concept about wait and notify. Okay, let me explain you this. So these methods are not part of the thread instance. Okay, wait and notify is basically called on the object on which the thread is going to operate on. Okay, so let's say one thread is trying to access a printer, for example, and another thread is also trying to access the printer. So on the printer object, you can call wait and notify method, because these two methods are part of the object class in Java. And if you recall from a Java videos, the object class is called as a master superclass because every class in Java literally extends the object class. Okay, and object has these two methods in them, which is wait and notify. Also, there is one more method called notify all. Okay, so what does this do is, let's say a thread T1, okay, and there is a thread T2. Okay, now what happens is T1 goes ahead and calls in the T1's execution, right, when it is trying to execute, it is trying to operate on, let's say, an object obj. It can call obj.wait. So moment it calls obj.wait, this thread T1 will go into waiting state. Okay, now T2 on the same object, it will execute some logic. Okay, so maybe get something from it or put something into it, something, whatever it is, the logic that it executes. Okay, after this, T2 will call object.notify. As soon as it says object.notify, immediately T1 will start working on this object and try to extract or execute or whatever logic it wants to do on the object. So if you observe this very carefully, T1 and T2, the one that calls object.wait is the thread itself. So it is a self-imposed waiting, meaning the thread will automatically go into call the wait on the object because it realizes that this particular object already has to be executed by some other thread. So when some other thread is working on this object, the thread T1, basically T2 is working, so T1 will go into wait mode. And once T2 is done executing the logic, T2 has to invoke the notify method on the object so that T1 can automatically pick up and do whatever it was intending to do with this object obj. This concept is very important because this is the principle behind several problems like producer consumer and all those other scenarios that you observe. And this also is very important because if you don't do this carefully, you will end up in starved thread states, because when the thread goes into the waiting state, it is an indefinite waiting. For instance, if it is not timed waiting, it is actually an indefinite waiting. So when in indefinite waiting, a thread can go into starvation, meaning a thread will not be able to ever execute the logic that it wanted to execute on the object, and because it will keep waiting for the notify method to be called on the object. Okay, so do keep in mind this is an important concept, and we'll talk about this in detail in other subsequent videos. For this particular video, I just want to give you an overview on this, and we'll also try to execute a program and show you how the two threads can cooperate with each other using the wait and notify protocol. All right, so timed waiting is just the same waiting logic but with a time attached to it, so or a timeout attached to it basically. So when I say timed waiting, let's say for 1000 milliseconds, which is basically 1 second, or let's say 5000 milliseconds. So the thread will wait for 5 seconds in the waiting state. That's called as timed waiting. An example of this is called as thread.sleep. All right. So when I say t1.sleep of, let's say 10,000, what will happen is this particular thread T1 will go into an idle state for 10 seconds. Okay. And if you try to get the state of T1, it will say it's timed waiting. And after 10 seconds, the thread will again become active. So timed waiting is generally preferred over normal waiting because it may not have to indefinitely wait and starve. Instead, post timeout, it can try to access the same resource or whatever it needs to do, or probably get terminated if it is not able to do the job that was intended to do. Okay. Next, we have the notify all method as well, right? That is also an important method. Let's say not just T1 exists, right? Let's say there is T2 as well. Okay, which also wants to operate on the object, and it also observes that T3 is there, for example. T2 we already mentioned here. So T3 also wants to execute on the object, so it also does object.wait because it is also waiting. All right, because someone else is executing it. And when you say object.notify instead of notify all, only one of these threads will be awakened and they will execute on the object. The other one will still be waiting. So in such cases, if you say notify all, it will wake up both T1 and T3, and there will be a race condition between who is going to execute the logic on the object, because both of them wake up at the same time and you cannot determine which one will be executed first. One of them will be executed definitely, the other one will follow up. Okay, so notify all basically wakes up all the waiting threads, and notify wakes up just one of the waiting threads. Do keep that in mind. We'll talk about this in detail. Then we have another state called blocked. So blocked is a state which basically is kind of similar to waiting, but it is not exactly waiting, because in blocked state, the thread will not call an object.wait. Instead, it will directly try to access the object which is being executed by T2 in that particular moment, right? So all of this happens inside a synchronized block. We'll talk about synchronized block as well in detail. So what happens is when T1 tries to access T2 unauthorized without calling a wait and without waiting for the notify method, without even using the wait and notify logic, it goes into the blocked state because T1 doesn't realize that T2 is already operating on the object. So it will try to directly access the object, but it will fail to do that and will go to block state. Now, when in blocked state, it is actually an overhead for the scheduler who is actually managing all the threads, right? The scheduler has to ensure that the blocked thread gets unblocked somehow, or the block gets terminated maybe. So something has to be done in this case because the thread itself will not be able to manage it. In case of wait and notify, two threads have a mutual understanding. One of them will call notify and it will help the other one to start executing. But in blocked state, scheduler has to intervene to make sure that the blocked state either gets unblocked or it gets terminated. All right. So all of these states, right? Blocked, waiting, timed waiting, from all of these states, when a thread comes out of it, it will go directly to the runnable state and then go into the running state. None of the threads will ever go directly to running state. It has to go to runnable. From runnable, only when the CPU resource is available, it will go into the running state. So do keep this in mind. It cannot go directly to running state. Then the final state, which is terminated. Basically, terminated is the last stage of the thread. Basically, this means that the thread is dead. So once you reach a terminated state, the thread no longer is alive and it has completed the task that it was intended to do, or it simply failed to and it was killed. All right. So this completes the thread lifecycle. Just one more point I want to add before we conclude this video, which is when you're in the waiting, timed waiting or blocked state, there is a possibility that some other process, input output process, something gets to interrupt this particular thread which is waiting. Okay. At that point of time, it will throw something called as an interrupted exception. So either JVM will throw that out if you're not handling it with try catch, or else you will have to handle it so that this particular exception is properly acknowledged. Okay. So interrupted exception can be thrown on all the wait methods, all the methods such as thread.sleep, for example, which I was showing. So that also is capable of throwing the interrupted exception. So you have to keep in mind, this is very important, and that completes the video for today. So hope you liked it. Do hit the like button if you liked it. Subscribe to Code with Ani if you haven't already, and I'll see you guys in the next video. Bye bye.